Hello, in this video, we will be talking about the z-test for a single population mean using the p-value. When we are looking to perform a hypothesis test for the population mean, we have two situations. The standard deviation might be known or unknown. When the standard deviation is known and we are doing a test for the mean, then we use what we call a z-test. So the z-test is a statistical test for a population mean, and it is used whenever the population standard deviation sigma is known. The formula for the test value or the test statistic in a z-test follows the same rule as the formula for finding the z-score. You do realize that this is following the same format, the value minus the mean, divided by the standard error. Now, because we are talking about the sampling distribution of the sample means, we use the appropriate notation. We use x bar as the value, and we use sigma divided by square root of n as the standard error. It says right here what each one of those values or symbols stands for. Okay. However, this test statistic formula is something that we will not really do because we will be using the calculator and we will be using the z-test, as it says right there on the top. The z-test will display this value right away. However, if you need to do it by hand, this is the formula you need to use and just plug in the corresponding values. Let's go ahead and do some examples. Here is the first example. A tire manufacturer claims that the lifetime of its tires are normally distributed with a mean of mu equals 34,000 miles and the standard deviation of sigma equals 1,200 miles. A tracking firm using these tires suspects that the mean lifetime is less than 34,000 miles. To test the claim, the firm randomly selects and tests 54 of these tires, which gives a mean lifetime of 33,390 miles. Use a significance level of alpha equals 0.05 to test the tracking firm's claim. The first thing I will do is write down the given information in an organized way on a side, use the proper notations. So right here I have the mean, which is 34,000 miles, and the standard deviation, and they use the notation in the problem. Sometimes they don't use the notation in the problem, and then you want to make sure you use the appropriate notations because it really matters. Now, this is what the tracking firm believes, what they suspect. They suspect that the mean is actually less than. So let's just write that down because that's actually the claim, right? To test the claim, the firm will actually use a sample. So this 54 is the sample size, and the mean from the sample will be x bar, which is 33,390 miles. So make a note of all of these notations. Make sure you know how to do this on your own. And let's write down this is the claim. And what we need to do as a question right here is test. We will do a test for the mean to test the claim. Okay, and this is a step-by-step process. I've seen more than 5 steps, depending how you organize your steps. However, I feel a few things at each step, so I try to use only the 5 steps. And here we go. The first step, it is state the hypothesis and identify the claim being tested. I copied this down here. However, from now on, we will not be copying this down. We will know that this is what we do first, the first step. So the hypothesis will be H sub 0 and H sub A. Now, if I've done this correctly, I know that the hypotheses are among the given information. And I spot this, which is a strict inequality. And I know because it doesn't include the equal sign, this is actually the alternative hypothesis. This is the claim. I wrote it down there. So I already identified the claim. And this other one will be mu is greater than or equal to 34,000 miles. And that's it. This is step 1. Now, at the next step, we want to make sure we know which distribution we use. We want to make sure which command on the calculator we use. And we want to write down the level of significance. If you are required to do it with a formula to find these values, you will do it with the formulas. For our class, we will focus on using the calculator, okay? So because we are testing the mean and sigma is known, the sampling distribution is actually the Z distribution or the standard normal distribution. So we have to write this down, the Z distribution, because if we know this, then we know right away which calculator command to use, which will be the Z test. And then which one is the level of significance. The level of significance is right here. I should have put it down among the given information. It's right there. So I will just simply write down alpha is 0.05. Something else, something that I do at the first step actually, I identify, I will add this here manually, I'll identify the nature of the test or the type of test. And why I do this at the first step, because I know the type of test is given by the alternative hypothesis. And I say this is the claim for the situation, the type of test, because this one is less than, pointing toward the left side. This will be a left-tailed test. The next thing I need to do is perform the Z-test and find the test value, which is also called the test statistic, and the p-value. So let's do the test. When we do the Z-test, we look for the test. Click on stats and then use arrows to get to test. The first option that you see there is the Z-test. Let's hit enter. And this time we have summary statistics. So I will use arrows to get to the statistics, hit enter, and let's enter the information. So at this point, you should look at your node. And in the null hypothesis, the value that you see is 34,000. So let's enter the value right here. That's the equality. That's why I said null hypothesis. It's very important because it contains the equality symbol. That 0 right here means you have to put the value that is corresponding to the null hypothesis, 34,000. And the sigma was 1200. The information from the sample, and this is all in your notes, the mean was 33390. And this was based on a sample of 54. And right here, we have to choose the nature of the test. And that's why I've done that at the first step. This was a left tail test. So I want to make sure that mu is less than mu sub 0. This is what is in our alternative hypothesis. And I'm interested in calculate, hit enter, and these are my results. So you should see Z, and this is the test statistic or the test value. And you should see P, and this is the p-value. And of course, you will see the mean and the sample size. So let's write this down right here. At the next step, we are writing down the information we obtained using the calculator. Keep in mind, Z is the test value or the test statistic. And you can find that using the formula. However, we found this by running the Z-test, and I'll round it to 2 decimal places. Now, P, I will just simply say the p-value is, and make sure do not make the mistake of writing down 9.4. Just pay attention to scientific notation. So I round to the first non-zero digit. So I have 1, 2, 3, 4, and 9 is the first non-zero digit. That's a very small value. And this is all I need. Keep in mind Z and P value. Okay, and now I'll be able to make a decision and interpret the results. Before that, I would like to sketch the graph. So make sure you make sense of this information, because right now I will put all of this information in a graph just to visualize what's going on here. This is the Z distribution, right? Right here in the middle, of course, we have the 0. And right here we have the Z. Look at this Z. It's negative 3.74. So it's really, really far away from the mean, right? 3 standard deviation, almost 4 standard deviation below the mean. So of course, we do expect very, very small area. And that's what it is. This is the p-value. The p-value, which is that area which is very small. And now it's time to make a decision. The decision will be to reject or fail to reject the null hypothesis. And we know based on the p-value that we need to compare the p-value and alpha. P-value is 0.00009, very small. Alpha for this problem, if you look through your notes, is 0.05. It's a lot easier to compare these numbers if you have the same number of decimals, so I will add 3 more zeros to have 5 digits and 5 digits. And we can see that this is smaller, right? So we will say the p-value is less than, I can put the equal sign in there too, alpha. And if that happens, I will reject. And it's important to write down what? H sub 0. It's always about H sub 0. Now, at this point, after I make the decision, I need to interpret the results. And this is very important. Make sure you interpret the results by stating this phrase, and you have to do it in a correct way. We already have the format in the previous video. It is in your text too. So let's take a look at how this looks like for this specific example. So keep in mind, we have enough evidence to reject H sub 0. And remember, the claim was H sub A. So if you follow the table, you should be able to interpret the results. Your interpretation should always look like this. You have to state if there is or there is not enough evidence at a certain level of significance, and in our case, it was 5%, to reject or support the claim, okay? Now, in order to make this easier for you, this is what I always do. I look at my first step. And my first step for this problem was mu less than 34,000, mu greater than or equal to 34,000. And I know this was the claim, right? And my conclusion was reject the claim. So that was the first step. And my last step was, well, reject H sub 0. What does this mean? That means that I do not support, I am rejecting it. Now, it's not correct to cross it out because we can actually make mistakes by rejecting it. So I'll just try to make sense and visualize it this way. I'm rejecting it. What does it mean? That means that I'm left with this piece, which happens to be the claim. Now, to put this in words, I will say, well, there is enough evidence. Whenever I reject, I start with there is enough evidence to, am I supporting or rejecting the claim? Well, I am supporting it. So the word right here will be support the claim, okay? So if you check with a table, this is how you should write it down in this very specific situation. You'll get used to this. Just keep in mind, when you reject H sub 0, you'll always start with there is enough evidence, and then you will continue accordingly. Just look at your first step and the decision, okay? And if you get to failing to reject or do not reject H sub 0, that means you're rejecting H sub A, and you'll be left with H sub 0, and you can interpret it accordingly. Let's do one more problem. And this time I did not write down the steps. We will actually go through the steps without writing down the template. Here we go. A random sample of 50 medical school applicants at a university has a mean raw score of 31 with a population standard deviation of 2.5 on the multiple choice portion of the medical college admission test, MCAT. A student claims that the mean raw score for the school applicants is more than 30. Is there enough evidence to support the student's claim at alpha 0.01 or 1% level of significance? Let's write down the given information using the proper notations. So here is what we have. A sample size 50. The mean raw score is 31, and the population standard deviation is 2.5. So you see on this example, you'll have to make the connection with the symbols. The symbols are not written for you. Now, a student claims, so this is the claim, that the mean raw score for the school applicants, for the population, is more than 30. It means that this is what the student is saying. And I'll write down next to it, this is the claim. And then alpha is 0.01 or 1%. The question is there enough evidence to support the claim? Which means we will test the mean. We will perform a test for the mean because this is the claim, right? So let's do this step by step. So I will start with step 1, identify the null and alternative hypothesis, H sub 0, H sub A. I look at what is written down here and I do realize that here I have actually the alternative hypothesis. Mu is greater than 30, which happens to be the claim. And right away, I can actually say that this is a right tilt test, right? Because this is greater than, so this, if you look at this as an arrow, is pointing to the right. Now, H sub 0 will be mu less than or equal to 30. And I'm done with step 1. Step 2, what distribution do I use? Well, at this point, we learn only about the Z distribution, but the thing is, because sigma is given and we're testing the mean, we'll be using the Z distribution. We will be performing the Z test, and alpha is 0.01. So let's take the calculators and do the Z test. So if you've done this correctly, this is how the Z test looks like on your calculator. You put in mu sub 0 as 30, and you plugged in sigma as 2.5, which is right here. You have the mean from the sample, which is 31, and you have the sample of 50. So the sample size will be 50. And then we are doing this time a right tilt test, which is right here. After performing and hitting calculate, this is what you get. As you can see, Z is 2.82, which 83 actually will be rounding it to 2.83, and P is 0.0023. We will give this as an area rounded to 4 decimal places. That's what we've done throughout it. So here we go. I write down the results right here. Z is 2.83 and the p-value 0.0023. Now I can sketch a quick graph to make sense of this. This is the Z distribution. This time I'm dealing with the right tilt test, so it will look like this. Right here on the bottom, I have 2.83, which is the Z. And the p-value is right here, which is 0.0023. Now I have all the calculations to conclude the test, actually to make a decision. Let's do so. So the next step, I will make a decision. And the decision is to reject or fail to reject the null hypothesis. How do I get there? Well, I'll take the p-value, which is 0.0023, and compare it to alpha, which is 0.01. So keep in mind, you always start with a p-value. We can see that the p-value is smaller than alpha, which means we will reject H sub 0. And step 5 will be interpret. So let's interpret. You should always start with there is or there is not enough evidence. And yes, you should be patient and write this down to, well, actually, let's put in the significance level. I'll just say at alpha equals, and in this case, it was 1%. And you can put significance level or level of significance in here. 2, and you have to fill in support or reject the claim that the mean score actually is greater than 30. Now, because we rejected, we know that we should say there is. And if you're not sure, scroll up. Well, I will not scroll up because I already erased that. But look at your first step. There is enough evidence and you will support the claim that the mean score is greater than 30. So 3 components, these 3 will be something that you will add. Sometimes is not, depends on the situation. Sometimes you reject, depends on the situation. And sometimes, many times, this one will change. Okay, so keep in mind, these are the steps. And you will need to perform each test like that. I have the formal interpretation right here. There is enough evidence at 1% significance level or level of significance to support the claim that the mean raw score for the school's applicants is more than 30. Thank you for watching.